Hi everyone, it's me again. I am Professor Andrew Timming, the author of this textbook, Applied Statistics, Business and Management Research, and I want to welcome you to Chapter 3, Lecture 1. So you'll recall in the previous chapter, in Chapter 2, we explored the SPSS environment, the graphical interface for SPSS. This is the statistical software that we're using in this course to carry out our statistics. In this chapter, in Chapter 3, we'll be looking at basic descriptive statistics and graphical representations of variables of our data. We won't be doing any statistical tests just yet. We don't want to jump ahead of ourselves. Instead, what we want to do is to be able to understand basic information contained in single variables in and of themselves. Once you understand this basic information, for example, measures of central tendency and measures of dispersion, then you'll be in a much better position to move on to actually carry out a series of statistical tests. So let's take a look at some of the basic statistics and let's see how it goes. Here once again is the textbook that we're using for this lecture series. It's called Applied Statistics, and I hope you do enjoy reading it. You are, of course, most welcome to order this textbook, or alternatively, should you not want to fork out the money for it, you're also more than welcome to visit a university library, many of which will carry this book. Let's talk about descriptive statistics. You might be one of those ambitious data scientists who wants to immediately jump in and start to carry out statistical tests. You might want to say, I don't care about a single variable at a time. What I want to know is how this variable is related to that variable and how that variable is related to another variable. Now, I can understand that that is the bread and butter of statistics, the idea of looking at how variables are related to each other. But before you can get to that point of doing statistical analyses, the first thing you need to do is look at individual descriptive statistics, one variable at a time. Descriptive statistics tell you something important about each of your variables. And because certain statistical tests can only be used with certain configurations of variables, it's important that before you jump in to those statistical analyses, you first look at descriptive statistics. So what do descriptive statistics do? They describe and they summarize variables one at a time. Okay, so what do I mean by that? If you look at the responses to a single variable, usually what you see is just a bunch of unintelligible numbers. And these numbers mean pretty much nothing to the naked eye, right? So you could ask a question on a questionnaire like, how old are you? And you could ask that question to 2,000 people. Then you get 2,000 data points, and each data point suggests how old an individual is, how old the respondent is. But if you're just looking at 2,000 numbers in a column, you can't really identify anything meaningful from those numbers. So what you need is some method of reducing those numbers into more meaningful statistics. A meaningful statistic tells us something important about that particular variable. And the most commonly used meaningful statistics, descriptive statistics, include measures of what we call central tendency, so that would include the mean, the median, and the mode, as well as measures of dispersion. So dispersion is how spread out a set of scores are vis-a-vis the mean. as I said, there are two different forms of descriptive statistics that you'll want to look at for each one of your variables before you start carrying out statistical tests. And you'll want to look at these statistics, these descriptive statistics, one at a time. So firstly, we have what are called measures of central tendency, and I've described these as inward-looking statistics. And secondly, we have what are called measures of dispersion, and I've described these as outward-looking statistics. That's a bit of an oversimplification, but I think you'll understand what I mean when we go through an example of what these statistics look like. So firstly, the key measures of central tendency include the mean, the median, and the mode. You've probably come across these terms at some point in your mathematical career. So the mean is the arithmetic average, the average score in a distribution of scores. The median is the exact center point in that distribution of scores when they've been rank ordered from lowest to highest. And the mode is the most commonly occurring score. So each one of these are individual numbers, individual statistics that tell you something important or something interesting about what otherwise appear as a bunch of unintelligible numbers. The key measures of dispersion include the range, which is the difference between the lowest and the highest score in a distribution, as well as the standard deviation, which is a measure of the extent to which the scores in a distribution are spread out around the mean. So if they're very spread out, they will have a high standard deviation, or if they're not very spread out and clustered closely around the mean, then you will have a low standard deviation. Now, each one of these statistics in and of themselves tell us something important, but in combination, when you calculate both the mean and the standard deviation, they tell you something even more important. Okay, let's talk a bit about the mean. The mean can be defined as the arithmetic average of a set of scores. So the term mean and the term average are interchangeable, right? They mean essentially the same thing. So the mean is the average and the average is the mean. So the mean is an arithmetic average of a set of scores, and this statistic, important to note, is only relevant to ordinal and scale level variables. That is to say that if you're dealing with a nominal variable like gender or race or favorite color or type of employment contract, right? So let's take the last one, type of employment contract. You can be on a permanent contract, a fixed term contract, or no contract at all, for example, a casual employee. You've got three different categories there. There's no way that you can calculate the average there because the categories that you're using can't be rank ordered. One isn't higher or lower than the other. So the mean is only relevant when you're dealing with a variable that can be rank ordered from higher to lower, and only ordinal and scale level variables can be rank ordered. So what the mean is it is a single number that represents the most typical or the most average score in that distribution. Now, let me give you an example of what happens when you have extreme scores in a distribution. Let's take, for example, the question of measuring the average income or the mean income of a set of respondents. Let's say you ask 10 people, how much money do you make per year? In order to calculate the average of that score, of that set of scores, you would simply add up all 10 and then divide by 10. That would give you the typical score, the mean or the average score. However, if you have an extreme case in there, let's say you have 10 people, 9 of whom are normal wage earners, but one of whom is Elon Musk, for example, then having that extreme score will dramatically drag the mean up, right? So the average score will be extremely high, not because of the 9 normal wage earners, but because of the uh, pressure exerted by the extreme score. So extreme scores, both high and low in a distribution, can drag the mean either upwards or downwards. So as I said, if you want to calculate the mean, you simply add up all the scores in a distribution and you divide by the total number of scores. So how do we calculate the mean arithmetically? So let's walk through a hypothetical scenario. Let's imagine that 25 students take this statistics class. So now we know our sample size is 25. In other words, we have 25 separate scores. The students are assessed at the end of the semester on their knowledge of applied statistics. After all, that's the title of the book. And the final grades for the class are as follows. You can see them on the slide. I'm not going to read them out one by one, but you can see, a smattering of different scores. There's one person who got 100% in there, so that person got a perfect score. There are a few not so good scores. I can see a 48 in there. That's not a terribly good score. That would be a fail. There is a 60 in there. Not a great score. So what I'd like you to do with this distribution of scores, with these 25 scores, is to stop for a moment and calculate the mean by hand. Right? So recall that what you want to do here is to add up each one of these scores, and then when you sum these 25 scores, then you take that number and you divide it by 25, and that will give you the mean or the average score on the end of semester examination or assessment. So please take a few moments, just pause the video and calculate this number on your own. Okay, if you did your calculation of the mean correctly, you should have gotten 78.40 or 78.4. That would be the average or the arithmetic mean of those 25 scores. All right, having now calculated the mean, let's move on to talk about the second measure of central tendency, and this is referred to as the median. So the median, just like it was the case with the mean, is only relevant to ordinal or scale level variables. And again, the reason is that only ordinal and scale level variables are rank ordered from lowest to highest. If you're using a nominal variable where there is no hierarchy of scores, in other words, the scores are just different, then the median is not a relevant statistic. It is a meaningless statistic for you. So remember, we only calculate the median as well as the mean when we're using ordinal or scale level variables. We can define the median as the exact center in a distribution of scores. So to calculate the median, then what you would need to do is to rank order all of the scores from the lowest score to the highest score, and then find the exact center. And in some cases, the exact center will be a single number, in which case that will be your median. But in other cases, it might be two numbers. In other words, there is no exact center. There are just two numbers at the center. And when there are two numbers at the center of a distribution of scores, then to calculate the median, you just calculate the average of those two scores. In other words, you add them together and you divide by 2. Now, you'll recall when we talked about the median and we give the example of income, when there are extreme scores, the extreme high or low scores can dramatically influence what the mean score is. However, with the median, you take that influence out. So recall from the example we gave, there were 10 people we asked. what their income was in the past year. One of those people is going to be, let's say, Elon Musk. So he will clearly have the highest income of those 10 individuals. By calculating the median score, you're much more likely to get something like the average wage earner score. And the reason is that the extreme score from Elon Musk doesn't drag the median up in the same way it would drag the mean score up. So the median is simply the center of a distribution of scores. Okay, let's now move on to look at how we might calculate a median by hand. Okay, so these are the exact same scores as on the previous slide. Remember that we're assuming, or we're imagining, that 25 students have taken my statistics course, my course in applied statistics, and at the end of the semester, we've administered some kind of exam that will measure their knowledge of statistics. And these are the 25 scores from the examination. So again, we know our sample here is 25, and we have a distribution of scores, some of which aren't so good, like a 48, and some of which are perfect, like a 100, but most of them somewhere in between there. Now you'll recall from our previous exercise that we already know that the mean, or the arithmetic average here, is 78.4. The question we want to ask now is, what is the median of this distribution of scores? Now, it's easy to ask SPSS to calculate the median for us, but I think it's important that you also calculate the median by hand. Clearly, this would be impossible with a massive data set, right? If you had 22,000 observations, it would take you a very long time to put them in order of lowest to highest. In that case, clearly we would rely on statistical software to do this work for us. But because we only have a sample of 25 here, 25 scores, I think it is reasonable that you spend some time rank ordering these scores from lowest to highest, and then starting from the extremes, from the lowest to the highest, moving your way inward until you get to the exact center of this distribution of scores. So please take just a few moments now, press pause, rank order the scores, and see if you can find the median. Okay, if you did your calculation correctly of the median, you should have come up with a score of 78, 78.00. So not too far off from the mean in this case. Remember, the mean was 78.4, the median is 78.0. In this case, we don't have any extreme high or low scores to drag the mean up or down. But you can imagine if, hypothetically, even though it would be nonsensical, if, let's say, we made a typo and instead of that score of 100, we wrote 100,000, then obviously you could imagine that the mean would be substantively higher than the median in this distribution of scores. Okay, so let's then move on to the last and final measure of central tendency. This one isn't used very often because it is probably the least informative. However, it is the most common measure of central tendency for nominal level variables. It is less meaningful for ordinal or scale level variables. If you have ordinal or scale level variables, it makes much more sense to calculate the mean or the median. But if you have a nominal variable with no hierarchy in the response categories, then the mode is probably about the best you're going to get in terms of measures of central tendency. So the mode is defined as the most frequently occurring score in a distribution. And as I said, we don't use this measure of central tendency for ordinal or scale level variables because the mean and the median are significantly more useful measures of central tendency than the mode. Now, hypothetically, let's say we wanted to look at the mode of the distribution of scores in the 25 scores that we've just looked at. The mode would happen to be 78. And the reason it would be 78 is that you find 78 occurring 3 times in that distribution of 25 scores. Again, this isn't a meaningful way of measuring a central tendency, but just for the sake of illustration, if you look at the scores in those 25 scores, the only one that occurs 3 times is 78. So that would be our mode. As I said, it's not a terribly useful measure of central tendency, but it is one that you should be familiar with. All right, thank you very much for bearing with me to the end of this lecture. I hope you've learned a little something about measures of central tendency, particularly the mean, median, and mode. In the next lecture, we will look at measures of dispersion. These will include the range and the standard deviation. I look forward to seeing you then. Thanks, everyone. Bye.